Welcome everyone. Now we are going to cover the chapter continuity and differentiability, and today we are going to start with the basics of continuity. So let's start with the basics of continuity. So first we have to understand what is continuity. So if we see a continuous function at any point is defined as a function which gives same value at that point as well as the point just behind that point and the point just after that point. So अगर हम एक एग्जांपल से कंसिडर करें, लेट्स टेक द एग्जांपल ऑफ द फंक्शन f(x) इक्वल टू बॉक्स ऑफ x मींस ग्रेटेस्ट इंटीजर ऑफ x. फॉर एग्जांपल अभी हम इसके ग्राफ से ये समझेंगे, बाद में हम इस फंक्शन को भी डिस्कवर करेंगे. सो लेट्स ट्राई टू ड्रॉ द ग्राफ ऑफ दिस फंक्शन. So if I draw the axis, now let's see how the graph looks. So if you don't know the graph, then it's fine, we will learn it later. So now let me tell you, the graph looks like this. So the graph I'm drawing is the graph of function of greatest integer of x. So this is the graph. Let's look at a point x equal to 1. At x equal to 1, the value of the function is actually 0. But if I take a look at the point just behind 1, that is, let me write it as 1 minus. So the value is also 0. But if I take a look at the point just after 1, that is 1 plus, the value is 1. So I can say function's value at 1 is equal to function's value at the point just behind 1 and is 0, but it is not equal to the function's value at the point just after 1. So हम ये कह सकते हैं द फंक्शन इज डिसकॉन्टिन्यूस. ये तो हमने इस फंक्शन की बात कर ली. तो ऐसे हम पता करते हैं कि कौन सा फंक्शन कॉन्टिन्यूस है एंड विच वन इज नॉट. सो लेट्स टेक आवर फर्स्ट एग्जांपल. आवर फर्स्ट एग्जांपल इज गोइंग टू बी द फंक्शन f(x) इक्वल टू mod x. सो लेट्स कंसिडर दिस. अगर हम देखें, हम f(x) को इस फॉर्म में भी रिप्रेजेंट कर सकते हैं. इट इज -x व्हेन x इज लेस देन 0 एंड इट इज +x व्हेन x इज ग्रेटर देन और इक्वल टू 0. सो लेट्स कंसिडर. सो जब हम इसकी कॉन्टिन्यूटी देखते हैं एट पॉइंट x इक्वल टू 0, तो पहले हम इसमें LHL देखेंगे, यानी कि लेफ्ट हैंड लिमिट. इसको मैं रिप्रेजेंट कर सकता हूँ फंक्शंस वैल्यू एट 0 minus, that is the point just behind 0. So let's take a look at it. अगर हम इसको लिमिट में रिप्रेजेंट करें तो ये होगा x tends to 0 minus functions value at x. So let's see what is the functions value at x. That is, हमें यहाँ पर जो 0 से just behind वैल्यू है उसके लिए f(x) को सब्सटीट्यूट करना है. तो वो क्या है, तो हम वो नेगेटिव नंबर होगा just behind 0, तो हम यहाँ पर सब्सटीट्यूट करेंगे -x. अब हम जब x के अंदर 0 वैल्यू डालेंगे, देन द माइनस साइन डजंट मैटर. सो द LHL ऑफ द फंक्शन इज 0. नाउ लेट्स टेक अ लुक एट द RHL. वी विल गो द सेम वे, बट दिस टाइम द लिमिट गोज 0 प्लस फॉर f(x) एंड द वैल्यू ऑफ f(x) विल बी सब्सटीट्यूटेड एज पॉजिटिव x. सो लेट्स डू दैट. Okay, then again putting value of x here, it is again 0, and also the function's value at 0 is also 0. So we can say function is continuous. Function is continuous at 0, at x equal to 0. So this was our first example. Let's move to our next example. Our next example is f(x) equal to mod x by x when x is greater than or equal to 0 and 0 when x is less than 0. So again we will go by the method of left hand limit and right hand limit. So let's consider left hand limit first. So again putting on the limits, it is gonna be 0 minus. Again we are checking at point 0, at point x equal to 0, its continuity. So let me substitute here what f(x) is gonna be. We know that f(x), oh sorry, there is a little change in the function here. It is when x is not equal to 0 and it is when x is equal to 0. So here when we consider 0 minus, x tending to 0 minus, the function we take is this one because it is here x is not 0. So अब हम ये वाला function लेते हैं. So let's check when x is going to 0 minus. Let's substitute them. Let me do it in the rough area. It is 0 minus upon 0 minus. So it is not actually 0, it is a number just less than 0. If we consider mod sign, the negative number will become positive because 0 minus is a negative number. So let's say it is be something like 0 positive maybe, or 0 positive, but these numbers are the same. So let's cancel them. It's gonna be -1. Fine. So the LHL is -1. Let's consider the RHL. It is limit extending to 0 positive fx. Again substituting the same value of fx. So this time doing it again, we substitute here 0 positive and 0 positive here. So these both are same, giving me 1. So RHL is 1, and also function's value at 0 is 0. So LHL is -1, RHL is 1, and function's value at 0 is 0. So it is again discontinuous. Fine, that was an easy example. Then let's move to our next example. So the next example is the third example, is fx equal to sine x by x when x is negative, or by x when x is negative, and x plus 1 by x when x is positive or greater than equal to 0. So let's consider the LHL first. LHL is nothing but limit extending to 0 minus, and so we are considering a negative number, so we take fx as sine x by x. Let's do that. So now if we think over how the graph looks like of sine x around 0, it looks like this. So now if we see just number below 0, the value of sine x is something like a number just smaller than 0, or we can say a negative number. So here if we check out, so it's gonna be a negative number, and again x is also, so our this part becomes like this, so it's again 1. So our LHL is 1. Now let's take a look at RHL. RHL is gonna be limit x tends to 0 positive. Now we are gonna substitute fx as x plus 1. So let's do that. Now see, it becomes like 0 plus 1. So our LHL and RHL are both equal, and also the value of fx at 0 is also 1. We can check this from here. So what I am getting, my LHL is equal to RHL and is equal to function's value at 0. So this is a continuous function. So this was all for this video. In the next video we will take a look how we can check the continuity of functions by taking a look at their graphs. Thank you.